Thought experiments in science can sometimes seem like pie in the sky to the casual onlooker. Essentially, it's the physics of the imagination, rather than anything that can be easily proven. But thought experiments do have a very practical reason for being done in science. They can give you a framework in which to think that ultimately leads to something that you can more easily test. This has happened multiple times. Albert Einstein is a good example. He started by imagining what it would be like to try to chase a beam of light, for example. You can't actually do that, but that was the point, in that it ultimately led to special relativity, which was successfully tested. The thought experiment led him to the actual experiment. Another would be David Hilbert, demonstrating how counterintuitive the concept of infinity is, when he framed it like a hotel with infinite rooms. Such a thing doesn't exist, but if it did, it illustrates the problem. But thought experiments also give a method for stress testing ideas, which often leads to insights on how to proceed. The problem is, sometimes they don't. They hit deeper, and you end up in a situation with a conundrum rooted in physical reality that you never figure out how to resolve, or it takes decades or more. And for that reason, when that happens, physicists call them demons. While not literally demons, they are vexing and hard to reconcile thought experiments that have endured long term, sometimes without answers. Some are answered now, some aren't. The oldest demon in modern physics was devised by Pierre-Simon LaPlace in 1814. His thought experiment goes like this. He starts with Isaac Newton and his famous still useful laws. If you can predict how an apple will fall and describe it beforehand perfectly, which we can do, imagine an all-powerful intellect that knew information for all falling apples, planets orbiting, every particle, everything to the point it could predict everything that would ever or has ever happened. In principle, at least in the world of the big, you could predict the entire past, future, and present of the universe with absolute precision. There would be no uncertainty at the level in which we see the universe. The quantum world, not so much it turns out. But the physical world of the large we see, yes. Laplace's thought experiment was very early. In his day, he had little idea that a certain French emperor was going to soon escape his island exile and return to power, much less that a century later Einstein would publish Special and General Relativity, which created issues for his thought experiment in practical application. Quantum mechanics not long later would prove effectively fatal in exorcising this particular demon. After all, in those frameworks, relativity shows that you can't really know everything to the extent you would need to in the thought experiment, because everything is relative and two observers in different frames of reference would see events unfolding differently. They wouldn't agree on exactly what happened. And the limits the universe places on communication places limits on if you could ever build a machine so powerful as to be capable of knowing everything with the speed of light, limiting how fast information can propagate. One hand would never know what the other is doing. But there is a further complication here, keeping this demon in some way on life support. There is a spooky part of this, in that there is one thing that actually can do it, and it's the universe itself. Everything that's happening is contained within it. So if there is a Laplace's demon, it's the universe itself. By its very nature, all happening within it is information inherent inside it, which rears its ugly heads in concepts like simulation theory. Laplace's demon may not exist inside the universe, but it may exist outside of it, or is it overall? But the thought experiment does provoke thought in other ways. General questions about the limits of science, whether everything that happens is predetermined or not, and begs questions like if our own existence is predetermined and thus, in some sense, illusory. The next demon comes from 1876 and is known as Loschmidt's demon. This stems from an idea by physicist Ludwig Boltzmann, himself no stranger to thought experiments. He was where the Boltzmann brain concept originated, that topic for another video. Here he was trying to figure out entropy, the idea that systems tend to become more disordered over time. Boltzmann thought that this could be explained basically by zooming in to small scales and looking at the building blocks of the individual systems. And then came Joseph Loschmidt. Imagine a demon, though Loschmidt himself didn't actually call it a demon. It was named that later, that could freeze a part of space. Everything inside a cube of space is frozen in time, but everything inside, such as molecules, do still have a position and a direction they are traveling, which they resume when you unfreeze them. Loschmidt then says reverse the direction those particles are traveling, which violates no laws of physics. You would just be running everything backwards by changing its path, which is true of many fundamental theories that can be run forwards and backwards. It's just that the universe isn't currently doing that. It's only going forwards. On the level of molecules, no big deal. So they are just moving backwards from their original direction. Nothing special happens at the level of the molecule, except globally it does. The effect on a larger scale is weird. Here eggs unbreak themselves and leap off the floor back into the unfumbled hands that dropped them. Glasses unshatter and move back onto the table as the dog's tail that swished it off swishes it back on, and everything runs in rewind. This troubles physicists because the effect isn't a problem at all for individual molecules, but it's a huge problem for the aggregate, let's say the unbreaking egg. We simply do not see this happen in the world around us, but there isn't a physical reason why it can't. When it intuitively seems like there should be a prohibition, but there simply isn't one. Something, the arrow of time is usually how it's termed, is the only reason the universe doesn't do it. But that's weird in itself, because there isn't any reason for that either. It just is. And it got worse. Experiments done in the 1950s by Erwin Hahn were set up to use radio waves to nudge hydrogen atoms in water molecules into spinning in unison. This lowers the entropy of the molecule, which has the appearance of running backwards in time. But the key here was that when Hahn turned off his experiment, the molecule went back to entropy. It stopped rewinding. And we now know that temporary reversals of entropy can happen. But overall, for some reason, in this universe, no matter what, entropy always returns and wins. The perhaps somewhat unsatisfying reality is that the cosmos started in a very ordered state, and that meant that it only had one direction to go, which was entropy. It turns out that while there may be one way to make a system become more ordered against entropy, there are a ton of other ways that will do the exact opposite, simply favoring entropy over increased order. Unlike something like Newton's laws, there is a probabilistic aspect to entropy. You probably won't see it in reverse, but it can do it, but usually doesn't for reasons that aren't fully clear or satisfying. And that marginalizes Loschmidt's demon. We simply have to think of the universe as weirder than they did in the 19th century. But what is, simply is, as spooky as that may be. In short, the thought experiment has become less relevant the more we learn, as often happens with thought experiments. But the questions they raise ultimately lead to the answers to the demon. But in some ways, this demon remains on life support and may yet recover. Indeed, no one knew this more than Ludwig Boltzmann. In response to Loschmidt's demon, he actually abandoned his original approach after concluding it was a valid conundrum. This in turn led Boltzmann to think more in terms of statistics, something he's known for, and that led to his most famous work, the Boltzmann equation. This illustrates the usefulness of thought experiments in science, because through pondering that, even though the experiments may or may not be valid, thinking about them leads to something that is. Perhaps the most famous demon in physics and the final one, at least to date, and it dates to 1867 and James Clerk Maxwell. Aptly known as Maxwell's demon, this also had to do with entropy and the second law of thermodynamics. His idea was different than rewinding the universe. Rather, he argued that you could interfere with it on the molecular scale. So you've got this demon that can push around molecules or anything inside of a box with its mind. Inside the box is a partition with a trap door. This is always a strange thing in this area of physics. What happens inside the box, and so on. What if you put a cat in one, and many other thought experiments? The idea was that over time you could violate the second law of thermodynamics because you could separate out fast-moving particles from slow ones. There have been many solutions to this demon, and many fell flat. One was that maybe the demon had to do a slight amount of work to operate the trapdoor. That thinking moved to information. The demon would still have to process information to do anything. It had to remember positions, and memory isn't free. In the 1920s, Leo Szilard realized that if you strip down the thought experiment to a single molecule bouncing around the box, the demon could still extract free work from the system. But to do it, the demon still has to store memory, which takes energy. The second law remains intact. You just have to do work to extract work, and there is no free lunch. The full answer seemed to come from a physicist at IBM who pointed out that the demon also needed to clear its memory, and that generates heat. So the system is experiencing entropy, albeit in an indirect, again somewhat unsatisfying way. Why this was important was that the thought experiment led to the realization in technology that information actually serves as a kind of fuel. It can be maintained, it can be expended, and so on. It all converts energy into work somehow, and it's applied in computer science, and is very important in quantum computing. So an abstract 19th century thought experiment demon designed to promote thinking about entropy ultimately led to technological advancement that grows in importance today. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently still stuck on the turtle stampede fossil evidence of the Cretaceous period from my last video. In astrophysics, if you happen to see something once, chances are it happens a lot. And there may well have been many and often turtle stampedes during the age of the dinosaurs. I wonder what the T-Rex thought. And worth noting that paleontologists think that many of the dinosaurs, like the T-Rex, did not have exposed teeth, but instead had lips based on fossil tooth evidence. But if I were a T-Rex observing a turtle stampede, I would do it with a suspicious gaze. I mean, feeding is one thing, but a turtle stampede going through must have been either profoundly disturbing or psychologically damaging to the dinosaur or lunch. The Cretaceous was a very unsavory period on many counts, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.